But all of these functions that we wrote are basically there for you to use and for you to kind of, to answer the questions for the PA5 and to work with images. Because without this, you're going to have to learn about a whole bunch of other complicated like computer science stuff that we don't have to get into in this course. But this stuff is there to help you with all the problems that you have that we're going to be covering. So one of the things that we can do is image transformation. Okay, image transformation. And we were going to do this last lecture, but we ran out of time. So what we're going to do is we're going to work our way up to this moment. Okay, we're going to work our way up to this moment. So before we do the dimming, like changing the brightness, we're just going to do some transformations today. All right, so, whoa, that's me. Oh, I see. That's me in another one of these. Oops, sorry about that. All right, so what we're going to do a couple of things. First thing we want to do is bring in an image as a list of lists, okay, as a 2D list. Okay, what does that 2D list look like? Can anyone remember what those 2D lists look like for images? Anyone at all?
Would it be like the file name?
Yes. To get it, you have to use the file name, right? And the files will be found here in images, right? So here's images, this folder called images. And then you could use any of these images, right? I like the Shono just because I think it looks really cool, right? I just really like it. It's from an artist that I really like. But there's like a bunch of other ones. There's a cat that we use a lot. The star that's really small. The star that's really small, I think it's fine, but it's just really, really small. And I prefer to work with larger images, okay? But the star is really good because, this star, let's see, 1 second. That star is 10 by 10. So like we had the dog, the Cholo dog, that's like 700 something by 800 something. This star right there, very small. That's only, actually, you can actually count these pixels right here. 1, 2, 3, 4, 5, 6. Yeah, you can count the pixels on this screen right here. This is 10 by 10 pixels. Very, very small. Okay, very, very, very small. All right, but we're going to be working with a larger picture. Okay, so what you have to do is you put the name of the folder, in this case images, then you put a slash, then you put the name of the file that you want. So I'm going to put shuttle.jpg. Okay, it's just so we could print it out, because when we did shuttle last time, it was like, it gave me a big old error because it said there's too much to print out. Let's just print out my image for the star. Oh.
Oh, because it's a PNG.
Oh, geez, yes, it's PNG, not JPEG. Thank you for that. So JPEG and PNG, those are just two different file types for images. Either one would give you an image. I think PNGs are supposed to be like higher quality, and they save as much. They save much more data in the file type. Anyways, so here is our 10 by 10 star. Okay, that star. Let me open it up again, just so you can see what it looks like. Okay. That star, which is 10 by 10, is just this white border, right? This white border with a blue star in the middle, right? White border with a blue star in the middle. Let's look over here. So, when we look at the 10 by 10 2D list, we have our tuples. Each one of these tuples, what are we calling these for the image?
Red, green, and blue.
Red, green, and blue, right? Red, green, and blue, right? This is a red value, a green value, and a blue value for a tuple. And we're just going to call them pixels, right? Like pixels, the way that we know a screen works. where each individual little pixel, each individual little square has its own color. Okay, its own color. And so we have here 255, 255, 255. What color should that be?
White.
White. Because white is just all the colors all the time, everything. Okay? Tacked in. So it's white, 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 white. Not so white. Close to white, but it's not the exact color of white. Okay? This is white. White, 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 white. And that's it. Those are the 10 values. So as we're getting here, like this one that's like kind of white, kind of, not 100% white. We can see that here. Ah, man, you can barely see it here. Let me see if I can make it bigger. So on these 10 pixels, right, on these 10 pixels, right around there, it's not 100% white. It's kind of white, right? So all that to show you, this, okay, our 2D list. Are we following so far what this 2D list is? It's a representation of that star. Anyone confused at all about how that star maps into this 2D list? Yes, no, yes, no? No? Okay, cool. All right, so now, that was just for the purposes of loading the image. I want to use the Cholo one just because it looks a lot nicer, okay? And let's not print the image because we're going to get an error, right? This error of like too much to print out. But what I want to do, I just want to see what the image looks like, right? And what we have here is something called save image. Okay, save image. Save image will do exactly that. It will actually save your image, right? If you run it on the terminal. If you run it here, like on your Python code, it won't save it here on like these images thing. But we have this save image function that yes, you could actually save your new image in a file if you run it on your terminal. We're not going to have to cover that for this course, but just know that that functionality exists for save image. But we're also using save image so we can see what the image looks like down here. Okay? So, what does that look like? Let's try it out. Okay? So we have our image. I'm going to put save image, right? It's going to ask for two things. There's two parameters here. One is called img, and the other is called file name. Save image needs two things. The first thing is your image, your 2D list of tuples. Okay, that's what it's going to want. That's what it's going to need. And if it's not that 2D list of tuples, it's going to throw an error at you. Okay, that's one. Number two, it needs a file name. Okay, any file name you can call whatever you'd like. Right. So first I'm going to pass in my image. Then I'm going to pass in a file name, and I'm just going to call it my new Cholo. Okay. Oh, cool. All right. So now when we run this, we haven't changed the image at all. It should be the exact same image. So this is the original image right here. This is the original. Cholo.jpg. It's got like a white border. It's got a hexagon that's like all blue. It's got like a nice dark blue dog. It's got a butterfly, a monarch butterfly, some roses, a white rose, a red rose, a pink rose. And we're going to save that exact same image, right? All we're doing right here with this code so far is we're loading the image, we're making that 2D list, and we're saving that same exact image again under a new file name, my new Cholo, okay? So I'm going to run that. And when I run that, here on XStem, you're going to get a little tab. This little tab. This little tab is going to help you out a lot when you're doing your P5, so you can start to see exactly what you're doing in your program. Right? So, when you click on that, that's what it looks like. This is the new file, right? The new file, my new Cholo.jpg. Okay? And it looks exactly the same because we have not touched it yet. We have not touched it whatsoever. Okay? So, what can we do? What can we do to transform this image? One of the things that we did yesterday, right? One of the things that we did yesterday was just make it all black, right? All of it was black. Let's do that again, just so we can see exactly how that works. So, in order to make my 2D list change its tuple values, what should I do?
Use a for loop.
Use a for loop. Why? What should I do with this for loop?
You should go through each pixel in the image.
For each pixel in the image. Okay, that sounds like a good idea. Okay, so for, what should I call this?
Row.
Row. Great. For row. Again, we can call this whatever we'd like. We're going to call it row. In, what should we traverse?
My image.
My image. My image. Okay. Now what do we put in there? So now we have the row of the image. And for those that are not entirely sure why we're calling it row, remember, your image, let's pretend this is your file, your image file. And then you got your little dog. Okay. That's good. Cool. That's your dog, right? That's your image of the dog. The reason why we're using this word row, you can name it whatever you like. Again, you can name it Tyler, Caesar, Angel, Ella. You can name it whatever you want. But we're calling it row because this is my image. My image is a 2D list. The 2D list looks like this. This whole thing is the outer list, the big list. And then inside, that's one list. That's another list, another list, and so on. Okay? Again, another list, another list, another list, another list, and so on. Okay? Does that make sense of why we're calling it row? Each row that we're getting is this row of pixels. That's the first row. That's the second row. Okay? Does that make sense as to why we're calling it row? So when we're doing row, row is first equal to this, then row is equal to that, then row is equal to that, and so on and so forth. We're going down the image like this. That makes sense? Cool. So, now we have our row. Now what do we want to do?
Another for loop.
Another for loop. Okay. For. Why do we want this other for loop?
Because you want to go through each, is it tuple or tuple?
Tuple, right? Yeah, you want to go through each tuple? We can call it just like a pixel for now, but yes, it's exactly that. So, in images, a pixel, remember each pixel is just one little square, and that little square is going to have a color. Okay? So, right here. So these are the rows, right? The column, so we have our elements here, right? And this is like a tuple of RGB. This is another RGB. This is another RGB. Okay? Now, what are we going to want to call this? For what? Anything you'd like to give it?
PXL.
PXL, great. PXL, right? PXL, that's just the variable name we're going to give it in this inner for loop. This PXL first is going to be that pixel, then it's going to be that pixel, then it's going to be that pixel, and so on and so forth, all the way until the end with your last RGB, right? And then your pixel is going to be that. Okay? You're going to read all the way until the end so you get that last pixel at the very end. Right? Then, that's all while we have row at this very first one. When row changes, down here, right to the second part, pixel will then restart, and now pixel will go all the way here to this RGB. Okay? And then all the way through until the very end. That's how this nested for loop is working. We're going in and we're going to get that individual pixel inside of the image. Great. So you're saying pixel in what?
Row.
Row. Right? Because we have to put the row. This for loop is going to know to go through each one of these individual elements if and only if you tell it, I want for each pixel in the row that I'm looking at. So that second for loop, when it looks at row, is going to look at this row first, Then it's going to look at this row, then this row, then this row. Okay? What would have happened if instead of 4 pixel in row, what if I were to have done this? What would have happened?
It would have done the same thing as the first one.
It would have done the same thing as the first one for row in my image. So right now, row is going to be this row, then this row, then this row, and so on, right? All the way until we get to the end. For PXL in my image, if you had it like that, then PXL would also be this row, then this row, then this row, then this row. Because you're telling the system, for each pixel that I look at, and again, you can name it whatever you want. So that's why it could get confusing. You're meaning pixel, right? That's what you want it to be, PXL. But if you put in the wrong thing, if you put in my image, you're going to get the same thing, these rows, which is what row is trying to get. So now for pixel in row, okay? For pixel in row. Right. Right now, let's just print out pixel, right? And then let's just break, okay? Let's just break. So we can say, oop, you got a ton of stuff. Why did I get a ton of stuff? A bunch of white. Here's I have this break inside this for loop. Just because I have a break, that break is only going to associate to the nearest for loop. So this break is inside this for loop, it'll break out of this for loop. But this break will not break out of this other for loop. The second for loop, the bigger for loop, needs its own break. Break. Okay, ready? Now we have 1. We have this 1 pixel. 255, 255, 255. What color is that? White. Okay? And it is, let's look at my Cholo image. It's that little pixel right there. Can I? It's that one. That one right there. Okay? That's what we found. Cool. So now, we found a way to get to our pixel. Great. Now let's just make the whole entire thing black, right? Let's just change the image to be entirely black. How can we update each pixel to be a black color? First of all, what's the color for black?
All zeros.
All zeros. So right now, just put black is equal to all zeros. Okay? We have that. How can we update our image to have, instead of all these other RGB values, right? All the white first, then all the blue, then the blue dog, then the red rose, the pink rose, the white rose, the monarch butterfly, all those things. How can we update that to just make it all a black image? How can we do that? Any guesses of how we can update this?
We set PXL equal to all zeros.
Let's try that. Let's try that. PXL. So right now, PXL is what? PXL will be 2.5, 2.5, 2.5, right? This tuple. You're saying we should change this to be 0, 0, 0, like this?
Yes.
Should it be a tuple or should it be a list?
Tuple.
Tuple. Okay? We're working with tuples for each pixel. Now, we're saying our pixel is equal to this black tuple. We finish our for loop. Let's see what happens. Let's run it. Ah, darn. My image did not update. Why is that? Why did my image not update? I have pixel is equal to 0, 0, 0 now. Right? What could it be? has to do with mutability. Yes?
Tuples are immutable.
Tuples are immutable, okay? So when we say for pixel in row, what pixel is going to be, it's going to grab that, right? It's going to grab it, and it's going to create its own tuple, okay? So what it is, so pixel right now is like pointing to this RGB, right? That pixel. But what pixel is actually going to be, it's going to be its own RGB. When pixel is reading that list, it's looking at the item within the list, okay? And that item within the list is a tuple, which means when pixel is reading that tuple, all it is reading it. It's not going to go in there and change it, okay? So when we change pixel right now, we're actually not changing, the actual pixel itself. We're saying at the very beginning here, pixel is whatever that color is. It was 255 last time, right? Pixel's 255, 255, 255. It's white. And then we're saying the way that we have it written right now is whatever pixel was before, I don't care what it was. My new variable for pixel, I'm going to make that 0, 0, 0. But that only changes that variable of pixel. It will not change the actual pixel itself. So how can we update the actual pixel itself? What is mutable?
Lists.
A list is mutable. Do we have a list here that we're working with? Yes, no, yes, no. What is row right now?
List.
Row's a list. What is my image right now?
A list.
Also a list. So we could edit a list and actually change the list. How can we do that? What we could do is something like this, right? This is not going to be the answer just yet, but like my image at position of the row and at position of the pixel, we're going to change that to be 0, 0, 0, right? What this is doing now, and again, this is not the answer just yet, because right now row is a row, row is a list, and pixel is a tuple. So this is not really going to make sense to the image. That won't work, right? But it's just an idea, right? Maybe it'll help better if instead of saying row and pixel, I'm going to call this X, and I'll call this Y, right? At some position in the image, I want to change it to be this tuple. This will update the image, right? This will update the image because images are mutable. Sorry, lists are mutable. And we're creating our image made out of a 2D list. Okay? So that means we can go in here into my image, access the exact position of the pixel that we want to change, and then replace it with this new pixel. That we can do. Right? That we can do. So how can we get the position instead? Yes?
You could use like ranges instead of just my image. Row.
You could use ranges instead of my image. So right now, row is going to be the actual whole list. The row list. That's what it will be. The whole row list. But we don't want it to be the list. We want the range. We want a position. We want it to be this. Right? The way that we can do that is, again, using something from the CSE 8A image library. Are we going to edit the CSE 8A image library? No! We will not edit the library. But we will use the functions that it provides. One of the things that it provides is height. Height of my image. Okay? Height of my image will get you, it'll get you the full number of rows. The height of the whole image. Okay? So is this going to work for row and height of my image?
Range and height.
The range and the height, okay? Height is only going to give you a number. So if we were to do, let me just cover this out really fast. If I were to print out height of my image, if I were to run that, it's going to give me 800. It's just a number, okay? We want to use that number, right? We want to use that number to find out how far we're going to go down with the range. Okay. So now row before, when Tyler told us to put row, what was row before? When we had it over here.
A list.
Row was a list, right? It was this list and this list and this list and this list. What is row now?
An index.
An index? What type is this?
It's int.
It's an integer now. Instead of the actual row itself as a list, row is now only going to be the numbers 0, 1, 2, 3, 4, 799. It goes all the way up to 799 only because right now our image, the height is 800. And the range of 800 will get you all the numbers, all the integers from 0 all the way up to 800 exclusive. So all the way up to 799. Okay? So now we have a row. And that gives us our first position, the row. But pixel right now, pixel is still up in the air. If you put 4 pixel in row, row is going to be a number now. Row is an integer, so that's not really going to work. That's not really going to work. Because now what's happening is you're saying for pixel in 0, for pixel in 1, for pixel in 2. For loops don't work that way. You can't do a for loop on a number. You can do for loop on a list of numbers, but you can't do a for loop on a number. So we have to update our second for loop. What should we update this to? For pixel in what?
Range of width.
The range of the width. Okay? Just like we had height before, we also have another function here. We have the height, right? The 2D list representation of an image. And then the width. Width of the image. Takes in a 2D list representation, returns the width of the image. Okay? So now width is also going to be a number. It's going to be just an integer. It will not be the list. So, you said range of the width of the image. Right? Is that what you said? Cool. Now, so now PXL is a number, right? The PXL is going to be 0, 1, 2, 3, etc. So now I have my image at position row. Okay, so before we get into all that, what will this return? What is this going to show us? My image at position row.
A row.
Is going to give you a row. What type is this row going to be?
List.
It's a list now. So when you say my image at position row, row is a number. So when you say row is 0, my image at position 0 is going to give you that first row, okay, of numbers. The actual list. The actual list itself. Okay? But now, I want to edit a position within that list. Which numbers should I use there?
PXL.
PXL. Okay? We use PXL now because PXL is also going to be a number from 0, 1, 2, 3, up until a certain number. And PXL will stop all the way up to the the width of the image. Basically left to right. So whatever this last number is going to be, that's the last number of pixel. The last number. It's not the element itself within the list. It is a number that represents the position in the list. Does that make sense? We're looking at positions here. We're not looking at the actual item. So when we do my image at the position row, at the position pixel, what is that going to give us? What type is that now?
Tuple.
A tuple, okay? This is going to be a type of tuple. The reason for that is because my image, again, is the to-do list. When you say my image at position row, that's going to be now the one-dimensional list. And that list has a bunch of tuples in it. So when you say my image at position row at position pixel, it's going to look at the actual tuple itself. Okay? It's going to look at the tuple itself. So now we say my image at position row, position pixel. What can we make this now? How can we change this to be the black color, 0, 0, 0?
Just with like an equal sign?
Just with an equal sign. Why is that?
Because now you're mutating the list, not the tuple.
Exactly right. When you do it this way, we're not looking at the tuple like this. This is how we had it before, right? We're not saying pixel is this tuple, and we change the pixel itself. But when you change the pixel itself, it's not really updating the list. Now, this way that we're doing it, my image at position or position pixel, this will tell us, go to that exact spot, and I want you to update whatever's in there. I want you to update that spot. So what should we update it with?
The 0, 0, 0 tuple.
The 0, 0, 0 tuple. 0, 0, 0. Let's run that. Hey! It is now a black square. Or rectangle, I should say. It's now a black rectangle. We did it. We updated the actual 2D list, changed the values of the original tuples to be this just totally black square. Okay? Great job. Does this make sense of how we got to this position? How did we got to this place? Okay. Let's assume now, instead of making the entire thing a black rectangle, let's say I only want to make the first half of the image top to bottom. Let's say now I have my image. I have my dog. But now what I want to do is I want to go halfway through and everything on top, make all of this a black pixel. How can we do that? Right now, we're changing the entire thing to be black. We go through every single pixel, every single element, and we change all of it to be black. How can we do it now? So that instead of making it all black, top to bottom, all black top to bottom, how do we do it so that we only do the first top half, top to bottom, top to half, black? What can we change?
The row range.
The row range? For row in the range of the height of my image. Okay. Right now, row will be every single position of the entire image. Top to bottom. Because that's what height's going to give you. Height's going to give you that number. Height's going to give you this number. So right now we're saying from the range of 0 all the way up to that number, exclusive. How can we change it so that now we only go up to halfway?
Divide height by 2.
Dividing our height by 2. So now what we're doing here, if we divide by 2, what we're doing now is instead of saying, I want to go through every single row of this image, you're saying, I want my row to be every single 0, 1, 2, 3, all the way up to the height of the image divided by 2. So, let's assume that the height of our image is 800. And we want to go all the way here. Ella, what number would this be? Halfway through.
400.
400, exactly. We want to go all the way to 400. And the way that we do that is with this. We're saying, give me the height of the image. In this case, it's 800. And I want you to divide that by 2. Okay? Should we change anything else? No. Why not? Angel, why should we not change anything else?
Because the width is the same.
The width is the same. We want to do the whole width of the image for every row that we look at. Right? Great. Why don't we change this?
Because you already changed the, in the first, for loop, we already changed the row divided by 2.
Yeah. So row will only go up to whatever the height is divided by 2. Great. Should we change anything here at all or no?
I don't think so.
No, we don't need to. Because row, once it gets to the number 400, it'll stop. Because it doesn't say, give me the range of 401. It doesn't say range of 402. It doesn't say range of 800. It says range of 400. So it's going to go from 0 to 399, and it's going to stop. Okay, so when it gets here at 399, it updates that. We go up to here and it says 400. We're not going to go into this for loop at 400. We're going to stop because that's where we're telling you to stop. Okay, let's run it now and see what happens. Run it. Uh-oh. Float object cannot be interpreted as an integer. When we do range, range is only going to accept integers, right? Right now, when we're dividing, we're getting a float. What can we do to change it? So essentially, yes?
You could either do like the divide or like the type switch.
Yes, you could do it one of two ways. You could either do the divide, the integer division, right? Integer division will just forget whatever's at the end of the decimal place. It'll just drop it. You don't round up or round down, you just drop it, right? Or you can do this. How do I change this into an integer?
Int and then parentheses.
Into parentheses, like that. This type conversion, right? You're changing the type from a float to an int. I like the double divide. That's just me personally. But you can use the type conversion. Let's run this now. Ta-da! That's your new image. You did it. Now we're going all the way up to halfway. And we're changing it all to be black. How can we do the same thing, but instead of the top half being black, let's just make the first half being black. So instead of like this, the way that we had it before, now, what if I want it to be like this? Our dog. Instead of the top half being black, what if I want to do like this? The first half to be black. Oh, you know what? Let's just change it up. Instead of black, let's make it red. How can I do this instead? Okay? Let's assume the width of this is 750. And we want to get to halfway point. Caesar, what's the halfway point for 750? I actually don't know either.
375.
375? I'm going to take your word for it, Caesar. If you're wrong, watch out. I'm just kidding. 375, right? So now we're going to want to do the first half left to right to just be red. Just the color red. All right? How do we do that now?
You need to change the width of the.
Change the width. What do I change this to?
Also divide by 2.
Divide by 2, right? Because we don't know how big this image is, right? And we want this function, or sorry, this code, this block of code, to work for any image we give it. Maybe this image is 750 pixels wide, But what if my image was like the star and was 10 pixels wide? We can't be putting a set number in here. What we have to do is be dynamic and make sure we read to see whatever the image I'm looking at right now, give me that number and divide by 2. Okay? So right now we're dividing 700, I think it's 750, I don't know, it's like 700 something, right? We're dividing that one by 2. Is that gonna work?
We have to get rid of the double divide and the row range.
Yes, we have to remove this double divide from the row range. Why is that? What would have happened if we would have kept that double divide?
It would have only printed the top quarter of the image.
Done. What would it do, sorry?
It would have changed the top quarter.
This top quarter. Because what it's going to do is going to do halfway through the row, and it would have done halfway through the width. Right? And we got this little section. And what color would it have changed that to?
Right now it would have changed to black.
Right now it would change to black. Right? Now we updated our rows. So right now we're going to do the whole half to be a certain color. Right now it's black. How do we change this to be completely red?
The first number of the tuple, we changed it to 255.
255. That is the max value for an RGB value. Right? So now we're saying, give me all the red you got, and then no green and no blue. Let's see if that works. Run that. Hey! First, the half of this image, left to right, is now red. Let's change it so now the first quarter is green. How can we do that? We were very close before. We were doing it over there. How do we do that?
We have to double divide back to the row range.
Add the double divide back here.
I'll tell you. Here.
Oh, whoops. Thank you for catching that. Then what do I do?
Change the tuple values.
To what?
That one back to 0, and the middle one to 2.
255. So now the first quarter of the image, like that over there, should be green. Ta-da! It's now green. We did it. Any questions on how we got here? Any questions at all? Okay, great. Now, what we can do is try and change, instead of making it all one solid color, that's boring, right? That's like a kid could go up, if you give my son, who is currently 11 months old, and you give him a piece of paper, and you give him this image of the dog, and you give him a green crayon, he can do this, right? He'll just color it over with one solid color. That's fine and dandy. We can do that. Now we can change it to a solid color. But what if we want to do something different? What if we wanted to now make it like a filter, right? We want to change it. Wait, actually, before I do that one, TAs and tutors. For the PA5, what are the 3 things that they have to do?
The grayscale one.
Grayscale 1. What's the other one? Double check, because I don't want to like give you the PA answer right now if I was supposed to be doing that.
It's great. There's a black and white, there's flip and image horizontally, and then wolf territories.
Wolf territories. Okay, great. So we can do this. I just wanted to double check and make sure I wasn't giving you the answer to one of the PAs, right? So now, instead of like giving my son this image and a green crayon and he can just color right over it, what we want to do now is do a filter, okay? What we want to do is get whatever was before here, and instead of completely covering it in green, what we want to do is like maybe now shade it in green. We want to shade it. So keep some of the original, like I want to see that ear still, right? I want to see that ear from the dog still. But now what I want to do is make sure that it looks similar to this other ear, right? It looks similar to the original ear that was here before, but instead of completely covering it in green paint, right? And just washing it away, washing away any sort of semblance of what the original image was. What I want to do now is I want to look at that ear and change it to make it greener, but I don't want to make it completely green. So what I want to do is keep some of that original values of the pixel and just make it more green. All right? So how can we do that? Right now, we're going all the way to the pixel element, right? We go to the actual position of what we want to change. All that's fine and great. But now what we want to do is update only one of these. So like, now what we want to do is make the green one 255. But instead of changing your red and your blue values to be 0, I want to keep the original red and the original blue of each individual pixel. How can we do that? How can we do that? So what's a couple things that we know? Right now what we know is we want to go through each one of those pixels that we want to look at, right? We want to update that position of the pixel, that tuple, with a new tuple. So all of this is good so far. But we don't want them to be 0. We don't want red and blue to be 0 now. I should remove those zeros. But we do want the middle value of green to be 255. We want to keep that. Now we have to update these two things. Right? We basically have to fill in the blank here and here. What do we put there? What we want there are the original values of whatever pixel was there. So for example, at the very top left, right, we have a pixel that is totally white, 255, right? So what we want to do is keep our 255 on the left side and keep our 255 on the right side to make our red filter, or sorry, our green filter. But how do we know what the original values of the pixel are? Any guesses? Yes.
Like on line 7 where you say my image row pixel.
Yeah.
You could access like the red value by putting like a hard bracket 0 after.
0. Like that?
Yeah, not to change it, but like you would copy and paste that part and put it inside the tuple.
Oh, okay. So something like this. Like that?
Yeah.
Great. Then what do I do over here?
The same thing, but instead of a 0, you would put a 2.
2. So what it's doing here is it's accessing the original tuple before we update it. It's accessing that tuple and it's getting that value, 0, the R value. Same thing with the B for the blue value. Let's run that and see what happens. Whoa! Now we have this green filter. I can still kind of see that ear now, right? We're not completely changing everything away from what the original image was. I can still see the outline of the ear. But now what we're doing is we're doing a filter, right? A filter. And we're changing it to be kind of green. We're shading it to be green. Does that make sense of what we're doing here? Yes, no, yes, no? Any questions on why this is working, why this wouldn't work? No? I don't know? All right. Cool. So now what we're doing is we're going through our entire image, or sorry, the first quarter of the image, the first top half and the left to right half, this quarter, and we're shading it to be green. Now let's try and do something completely different. Right now we have like this white border. Looks nice. Cool. But what I want to do now is I want to get any pixel that's white and I want to invert it to be black instead. Okay? I want to change any white pixel values to now be black pixel values. How could I do that? Let me remind you. I want to grab any white pixel values, and if your pixel value is white, I want to change that pixel value to be black. How can we do that?
An if statement.
An if statement. Let me remove all this first. If. What do we check?
My image,
My image.
and then we index a row, and the pixel is equals to the tuple 255.
Yes, 255, 255, 255. This is the white color. Okay? Is that it? Do I want an and? Do I want an or? Do I want anything else?
No, because you said all white values.
Just all white values. As long as they're white values, I'm good with that. Okay? Now what should we do?
My image part again.
My image, row, pixel,
Set it equal to black.
equal to black.
Yes.
Yes. This is black pixel. So, Angel, what is this going to be doing now? Can you walk me through each one of these lines of the code and tell me what's happening?
Yeah, so it's going to get the height of the image, and it's going to divide by 2.
Right.
Since we only want like the quarter of the
Yes.
quarter,
So what is this going to give us left to right or top to bottom half?
top to bottom.
Top to bottom half, right? Okay, great. Then this line, what is this line going to do?
It's going to give you the width of the whole image.
Yeah.
It's also going to divide by 2.
Divided by 2, so halfway through.
Yeah, since we only want it to be halfway through.
Okay, great. Then what is this going to do?
Let's see. Oh yeah, that's going to give you all white. You want to replace the white values with black values.
Right? So what is this line 7 doing then?
It's going to replace. It's going to check for white values.
It's going to check for white value. So this line 7, all it's doing is checking. If my image at that position is white, right? If it's equal to the white tuples, then what is line 8?
And then it's going to change all to black values after.
It's going to get that same position of my image at row pixel, and it's going to make that equal to black. Let's see what that looks like now. Again, this is the original image. This is the original image. What we're going to do is look at any white value and make it black. Ta-da! Whoa! What's going on there? So first off, it's only looking at the first quarter, right? It's not going to look at anything below here. It's not going to look at anything to the right here. Great. Then it's only going to look at the strictly white values. Completely white. All of these little like edges, what's happening here is that those values are actually not pure white. 255, 255, 255. Okay? Those are not completely pure white, which is why it's looking all funky. But to be honest, y'all did an amazing job. That's exactly what we were looking for. Okay? What if I wanted to do it to the entire image and not just the first quarter of the image? Ella, what should I do? Instead of doing this top like quarter right here, how can I change my code to be the entire image instead? And if you're not sure, it's totally fine too.
Basically, multiply.
Multiply? Should we multiply? Where should I multiply?
The bottom one.
This bottom one? Here?
Yeah.
Multiply this by what? 2. Okay? We could do that, right? But right now we're dividing by 2 first, then we're multiplying by 2. Instead of dividing, then multiplying by 2, what we want is to just not do any math operations on it at all. So what we could do is instead of dividing, then multiplying by 2, we could do this. Right? We could do that. And the reason why this is more important to do it without changing anything is because if we do integer division, then multiply by 2, there's a possibility that we forget that last row. Okay? That last row that we don't capture. Right? So we want to do all the rows. Is that it? Is this all I should do? Right now you change the width, right? So now instead of looking at the first half left to right, when you changed it, instead of looking at just up to here, now you're looking at this entire thing. Okay? So then how do I change it again? All of this code right here. So then instead of only looking at the top half, I look at the entire image. Ella, one more time. What should we do?
What was the question?
No, sorry, yeah. So right now, the way that we have the code, you did fix it, where instead of this, right, the top quarter, now we're looking at, sorry. Sorry, no. Instead of, so right now, it used to be like this. You changed it, so now we looked at the entire width. So now we're looking at this. Right? So now we get the entire width. But now I also want to get this other bottom half. I want to change all of this. How do I change this code now? So that I look at all of the pixels left to right and all the pixels top to bottom. What should I edit?
Maybe like remove the divide sign.
Remove the divide sign? Let's try that out. Tyler, is this going to work?
It should,
It should. Why?
because you removed the divides.
And when I do that, what's going to happen to row?
It's going to like see the whole image.
It's going to look at the entire image, top to bottom. And then Caesar, why is this going to work?
Because you're going through each tuple. and
Each tuple left to right,
left to
right? Everything from the entire width. Angel, why is this going to work? This line right here, line 7.
Because it's checking for the whole image, and then, so it's checking if, if the pixels are all white.
If the pixel is all white, entirely white. It has to be 255, 255, 255. If it's like lightly creamy colored white, even if a little bit is not 255, 255, 255, completely white, then it's not going to change it, which is fine, right? Because well, that's what we're looking for. Let's run that. Ta-da! Now we look at the entire thing, the entire image, and any pure white pixel that we find, we're changing it to be purely black. Does that make sense? Of why that works? Great. How much time do I have left? I feel like we're doing great on time. 20 minutes left? Okay, so now, what should we do? Oh, you know what we should do? We should do what we were going to do in the first place. Duh, is mine. Okay. Now, what we want to do is this. We want to transform our image to make it slightly dimmer. When we have this image and it's going to here, is it getting lighter or darker? Darker. Which means we're going closer to white or black?
Black.
Black. Which means that our RGB value should be going closer to 255 or to 0?
0.
To 0. Okay. And are we completely removing the original values of the tuples, or can we kind of still see the cat in this image?
So kind of safe.
You still kind of see the cat. So you still retain some sort of that original information of the pixel itself, right? We still retain some of that original information from the pixel. So, what do we want to do now? So now we want to do it to every single pixel. Every single pixel we want to make it slightly dimmer, closer to black. right? Closer to black. So we want to do it for every pixel. So should we have this if statement here? No. Okay? No. And we know we're going to want to have kind of the original pixel, right? But not entirely the same. We want to make it darker. So what we can do also is look at our original pixel values and get my image at position, row, and pixel. So what this variable is doing, orange pixel value, original pixel value, what this is doing is it just goes to the image and looks at whatever that pixel is, that tuple. It's not going to change it, it's only going to read it. So it's going to read the original pixel value. And that's it. And now what we want to do is change the values to be closer to 0. We want it to be closer to 0. Not all the way, but closer. How can we do that? How can we get a number, like any number? Let's think of the number 27. How can we get this number 27 closer to 0? Closer, but not necessarily 0. How can we get it closer? What kind of math operations can we use?
Multiply or subtract.
Multiply or subtract. So let's look at multiply and let's look at subtract. So with subtract, 27, and you subtract something, you're going to get closer to 0. Great. 27 minus 26 is what? 1. Is 1 closer to 0 than 27? Yes. This works. The minus. Let's look at the multiply. 27 times 2 is what? 54. Is 54 closer to 0 or further away from 0? Further away. So not necessarily the multiply, but you're getting close.
I was saying if you like multiply it by like 0.8 or something.
Ah, okay. So if you're multiplying by 0.8. I don't have an eraser here. Oh gosh. So instead of multiplying by a whole number, you're saying to multiply by a float. Right, sorry, a decimal value, right?
Yeah.
So instead of, so multiplying, but specifically, numbers less than 1. Is that what you mean?
Yeah.
Any number less than 1, you want to multiply by that. Okay, great. You can do that. What's another way of doing that same thing?
Divide.
You can also divide. So if you multiply something by 0.5, what are you doing?
Gets lower.
It gets lower, right? Let's look at 10. 10 multiplied by 0.5 is what? 5. 10 divided by 2 is what? 5. So yes, Tyler, you are correct. You could multiply, but you have to make sure that you're multiplying by a number less than 1. And when you're multiplying by a number less than 1, it's like you're dividing as well. So you could use either one of these two. Multiply or divide. You got ahead of me. I was going to show first that you have to divide, but then you can also multiply. But yes, you could use multiply, but you have to multiply by a number less than 1. Only less than 1. Okay, great. So now we can get closer to 0 with either a multiply, a divide, or a subtraction. What do we want to try out?
Divide.
Let's try divide. So now, let's say our new R value. Our new R value will be orange pixel value at position 0 divided by, what do we want to divide by? Give me a number, any number. 2. If we're dividing by 2, we are making our numbers half as much, which means we get halfway through closer to black, whatever those numbers may be. So if it was 255, and we divide that by 2, what is our new value? 255 divided by 2? I don't know. I should have my calculator open at all times. I keep on asking y'all for these math operations that I don't know off the top of my head. 255 divided by 2 is 127.5. Okay? So, divided by 2. Is this going to work? So far? Right now we're just looking at our new R value. We haven't updated anything, but we're just trying to look at new things. Should this work?
Yeah.
Cool. New G. How do we get the new G?
Would be the same thing, but with 1.
With 1. What about 2? Yes?
Do tuples accept flips?
That's a great question. When the value is 255, our new value is going to be 127.5. To answer your question, tuples can accept floats. However, tuples for an image, like an RGB values cannot accept floats. They must be integers. So instead of divide, what can we do?
Double divide.
Double divide. Cool. Awesome. New B, original pixel value at 2, divided by 2. Then what do we do? So now we have a new R, a new G, and a new B. These are all ints, right, because we double divided. Are we done? No. What should we do? Angel.
We have to like put them together.
Put them together. Something like this. New R, new G, new B. Like that? Like a tuple?
Oh yeah, but then we have to like make sure that that we could reference like like a variable.
A variable? What should we put for the variable?
Combined.
Combined, sure.
Combined RGB.
Combined RGB. Are we done now?
No.
No. What should we do next? Ella, what should we do? We now have our new R value, our new G value, our new B value, and we have a new variable called combined RGB, and we have a tuple of the new R value, the new G value, and the new B value. What should we do now to update our image?
Print.
Print it. Let's try that. So when we do this, and we run it, unfortunately what's happening is all we're doing is printing the value. We're not storing that actual combined RGB into our image. Okay? We're not adding it to our image or replacing the original value with this new value. So instead of printing, what can we do? We do want to use this combined RGB, right? But instead, what we want to do is we want to go to the image at the actual position of the row and the pixel. So we're looking at the exact position in the 2D list. And what are we going to make that now?
Equal to combined.
Combined RGB. Do you see what's happening here now? We're going to the actual 2D list. We're going to the actual position of that 2D list. And we're going to change it to whatever it was before. Doesn't matter what it was before. It's going to be something new now. Combined RGB, which is a tuple made up of our new R, our new G, and our new B. Let's run that. All right, remember, this is our original image. Let's see what it looks like now. Run. Hey! Look at that! We made it dimmer. We made the numbers a little bit darker by dividing. What if we wanted to do the same thing by using Tyler's method of multiplying? What should we have done?
Multiply by less than 1.
Multiply by less than 1. So we can do 0.5, right? This should give us the same image as we have right now. So again, this is our original image that we created as our dim value with the divide. Now if we multiply by 0.5, it's the same one. What if we wanted to make it even darker? What can we multiply by instead of 0.5?
0.9.
0.9? You're living on the wild side, Angel. We'll see what happens. Oop.
Oh, sorry, more lower.
Lower, right? I actually thought it was going to be darker. I really did. I completely messed up. So instead of 0.9, what can we put?
I think 0.1.
0.1? Because we're getting closer to 0, right? As we get closer to 0, we're making it even more and more and more dark, right? Closer to that 0 that we wanted. Run that. Oof, very, very dark. Very hard to see. I don't think you even can see it from the audience. Yeah, you can't really see it in the audience. But trust me, here I can see there's a hexagonal shape right here. Maybe that's too dark. Let's make it 0.2. Maybe that'll work. Does that look better? Can you see the dog a little bit?
See the hexagon.
Okay, you can see the hexagon. yeah, okay. So now we're making it dimmer, right? Great. What we could have done too is instead of keep on like updating, okay, I did 0.2, now I want to make it 0.25. I have to change all three of these. Instead of changing all three of these, what I could have done, how much time do I have left? 10 minutes. What I could have done is instead of doing that, we could have done my, I don't know, multiplier, and make that 0.25, and change it so that my multiplier is here. Right? So now I only have to update this one variable. 0.25 looks like this. 0.4 looks like this. Can you see that? Yeah, y'all can see that now a little bit better. Okay, great. We have now dimmed a value. Sorry, we've dimmed the actual image. What if we try to change this? Now instead of the choro, let's try to make it the cat now. Cat.jpg. The cat originally looks like this, and we want to make it dimmer. We just changed my image to be images at cat. Should we change anything here? Should we change anything else in our code so far? We keep it the same. Because the way that we wrote our program is that no matter what the image I'm getting, it could be 1,000 pixels long, it could be 10 pixels long. It could be 1 billion pixels wide or 2 pixels wide. It doesn't matter to us. We're going to programmatically go in and look at every single pixel and change that pixel value to be something else. Okay? Let's run that. Aha! Now we have our dimmed cat. This is the original cat. That's the original. And that is our new cat. It is now less bright. That makes sense? Awesome. What if I want to make it more bright? Right? So this original picture of the dog, it already is kind of dark in the middle, right? What if I wanted to see a little bit more of that color instead of being really dark? What if I wanted to make it brighter? What can we do? So if when we made it dimmer, right, making our things closer to black, when we light something back up, are we getting closer to black or white? We're going closer to white, okay? So that means we're going closer to the number 0 or 255? 255. So if I have my number 27, and I'm trying to make it go to, and I'm trying to make it closer to 255, what can I do?
Multiply.
We multiply?
Add.
We can add?
Exponential, like double.
Exponents? Wow. Yeah, we can do that. Yeah. Can we do anything else?
You divide.
I mean, yeah, technically, yes. You could divide. But if you divide, what do you have to divide by?
A factor. after less than 0, than less than 1.
You have to divide by a number less than 1, right? So you could divide, right? But number less than 1. Because when you divide something by less than 1, it's like you're multiplying it. Same thing. Okay? So now, let's try to make our image brighter. What can we do here? We're currently multiplying. Isn't this working?
We could multiply by like 2 or 3.
Multiply by 2 or 3. Multiply by 2. Let's see what happens. Let's run it. Oh! Python integer 272 out of bounds for unit U int 8. What does that even mean? Overflow error. Ah!
Well, is it because like since they multiply more than the than 255?
Yes. So the original pixels that we have here, right, for a dog, the first pixels that we see are white. They're already maxed out at 255, right? 255, 255, 255. They're already maxed out. So what we want to do is multiply any number, but if it hits 255, we want to keep the max at 255, right? We want to keep that 255. Like hit all the way up to that ceiling, but then if our multiplication goes higher, we just forget everything on top and we just stay at 255. What can we do?
An if statement.
You do an if statement, right? Let's see. What should we do? If
My multiplier
my multiplier
is actually
yeah, maybe not the multiplier. What we want to check to see is the actual RGB values. Is my R greater than 255? Is my G greater than 255? Is my B greater than 255? So if my new R is greater than 255, what should we do?
New R equals 255.
New R equals 255. Is that it? Am I done?
You have to do that for each value. So for non-underscores.
New G is equal is greater than 255. New G is equal to 255. If new B B is greater than 255, new B is equal to 255. Let's try that. Let's run it. Ta-da! We made it brighter. Actually, I want to look at the dog again. Run that. Ta-da! It's brighter now. It's brighter. I can see different details. Some veins of that dog. That's pretty wild. Didn't know that. It's pretty cool. But we're doing that to all our pixels. So, as you can see, our white flower kind of lost its definition because now it's getting closer to white. It was already super close to white. So if you make all the other creamy colors closer to white, it just becomes white, which is fine. Nothing wrong with that. We just made everything brighter, right? We could have done the same exact thing. Here, I have 2 minutes left. We could have done that same exact thing, but instead of doing this if statement, which is correct, by the way, this works 100% well. We just ran it, we saw, with 2 different images with the cat and the dog. A really neat one that I like to use is we had a function before called max and min. We could have used something called min. And what you're saying is I want the minimum between 255 or this other value. So it calculates that value. It looks at 255 and it says whichever one is smaller, I want to keep that one. Okay. Same with this. That. This is just like a neat thing. It's not a necessary thing, but you get the same thing. Okay, with min. Any questions on that? On how we got here? What if we only wanted to brighten up the first quadrant? How do we do that again?
Change the ranges.
Change the ranges to what?
It's divided by 2.
And divided by 2. for both. Run that. Hey! Now we only made a certain part brighter. What if I wanted to make the second one, just the second quadrant, brighter, and not that first quadrant? What do we change here? What we could do is we keep our range the same, or the top range, top to bottom, because we still want the top to bottom half, but I want left to right half. The one on the right side. What we can do is have our range. We had our range go from 0 to this number. What we can do is start from that number, from halfway through, and go all the way to the end of my image. Now we're saying start at the halfway point and go all the way until this endpoint. Run that. Hey! Now you can look at that second half of the quadrant. Does that make sense? I can do this. Remove that first floor divide for the rows. And now I get the whole right side brighter than the left. See what we're doing here? Small changes in your code could have huge impact on your actual program. Okay, we are 1 minute over now. Thank you so much, everybody, for joining me for another wonderful lecture. Work on PA5. This should help you out a lot with PA5. So I suggest doing that and going to lab and office hours, tutor hours, all the hours. Okay, we're here to help you with everything that you need. Cool? Thank you so much.